Hey, everyone. It's so good to be here. My name's Anirvan. I'm head of AI solutions at Palantir, and I wanted to talk about building AI models and agents with code. Um, you know, to many people out there, AI development is a code-based process, right? You get your Hugging Face, your Lang chain, you get some tokens, whatnot, maybe use Olama, you build something. And I think for anyone here who's built with AI in our platform, you've seen that we've taken a little bit of a different approach, right? We have a lot of wonderful low-code AI tools, right? Whether it's Logic, Agent Studio, Quiver, evals, and whatnot. And these tools have been great for us, right? They've allowed us to very rapidly, do over 1,000 boot camps, work with cross-functional teams of data scientists and subject matter experts, get workflows into production. We have an insurance company with a chain of over 75 different agents that are reasoning using some of these tools. But at the same time, when I'm out there meeting with data scientists and AI engineers, the question I get most frequently is like, this is awesome. How do I code in this environment, right? Like, how do I use I heard about some cool thing on the internet, or I have another project that I'm doing using code. Like, how do I do that with your platform? And so we're super excited to roll out some new functionalities. Of course, this has been possible to date, right? You can do anything in Foundry with sufficient creativity. But I want to talk about kind of like what's driving our intentional step forward here. And in order to do that, like it's worth saying that most of our AIP development work lives what I would say is below the waterline. It's not the UIs that you see, right? Gen AI development is really hard. And as we've been going, it's like we've had to tackle issues like, okay, what happens if you call your function 500 times? How do you scope the use of what tools reasoning can use to protect against prompt injections? How do you scale scenario analysis that was previously for humans to scenario analysis for robots? How do you make your actions faster? All of these kinds of things. How do you deliver models at scale? And we've been working really hard on these foundations behind the scenes, and our low-code tools have enabled us to deliver well to our customers, enable them to make progress, while we've kind of been building the plane as we flew, to be honest. And we've made a lot of progress, like even just to pick a random one here, like with action performance. Our action performance is more than 10x higher than it was when we started on the AIP journey, right? We've made a lot of progress here. Also with compute modules, many of these other tools that you saw, with virtual tables, right? Being able to have a reasoning agent push down compute into an external system. And so we're now in a position where we can really confidently roll out pro-code workflows that sit on top of the same foundation and really feel good about what will happen when people start baying on this. So I'm going to start by talking about talk through two of the most frequently asked workflows. One is on the model integration side, right? How can I use my own model or a fine-tuned model or a guardrailed model, whatever, throughout the AIP ecosystem? And then the second is more on the reasoning side, right? Can I use something like Lang chain or DSPy or any new thing that comes out to reason on top of the ontology using the ontology SDK that you've been seeing in the context of applications? And along the way, I'll talk about a couple of the new pieces of functionality that are enabling our more first-class versions of these workflows that have some other applications as well. So, cool. So maybe I'll hop over to my screen over here, if I could get my screen. Awesome. So we'll put on the hat of being at a bank. We're building a tool to onboard customers, and part of this is we want to be able to know, not just what's in our own ontology about these customers, but what's happening in the world, right? Are they wrapped up in something sketchy, right? What's going on? And previously we might have had people going around and looking for adverse media on stuff like Google, and creating reports that maybe look something like this, right? You put together a report and say, hey, we should onboard this customer or not. Maybe we want to use AI as part of this process. And we heard there's this this company called Perplexity that makes a fusion language model search system. And we got authorization to get a token to that, and we want to use this in AIP. What does that look like? Let me show you. So if you've worked in the platform, right, we have a lot of built-in Palantir provided models, right? This is infrastructure that we provide with the provision capacity and the logless security. But you also see in the model catalog, there's now a section for registered models. This is where enterprises can bring their own models and make them first-class models as part of AIP. And what is a registered model? It's just a function in the ontology. So, we'll start by, and I already pre-made this connection, right? So we need to connect to Perplexity. How do we do that? I don't know if someone can take care of that buzz. We'll do it through the same system that we use for connecting to data sources. And so here I have a Perplexity source here. This is a REST API source. How does it work? Exactly like how you'd expect, right? So we have our Perplexity endpoint. Hope this is big enough. Maybe I'll make this a little bit bigger. We've filled in our bearer token. This is kept securely. And we've also attached a network egress authorization, right? We don't want AI, we don't want anything in Foundry connecting, arbitrarily to things in the open internet. This egress policy is attached to this model and follows this model wherever it goes, so we can keep track of who's able to connect to this external source. We can add other controls in there that exist elsewhere in the system, right? So in this case, I haven't put any marking controls on this one, but if you wanted to prevent this from being used in context with certain data markings, you would be able to do so.
What's an example of that? Is that something like health data or something like that?
Yeah, I mean, so for most of the large commercial grade models, they're quite secure at this point, but especially for more experimental models where maybe you haven't had time to do a full information security vetting of a model provider, you might say that, let's say, ITAR data or certain health data cannot go to that endpoint. And that gives you time to get started on a bounded set of use cases without having to expose your entire platform to the risk of that while you figure out how secure you think it is. So it lets you move fast and set up those. In other situations, there might be regulatory constraints that prevent you from doing that. So this is there as an option to control how models get used. Awesome. So what I'm going to do is I'm going to hop into any of you who've used our functions, TypeScript functions in the platform. And because you mentioned anything in the functions registry is fair game. So what I've done here is I've imported a couple things, right? So we've gone in here and added a source, right? So we can go and add in a source. This is our Perplexity source. I've already selected it. That makes it available for use inside of this function. And I've also added another thing here, which is called a function interface. We have a few different function interfaces available here. And I'll talk a bit more about what these are, but these are basically strongly typed ways to declare that a certain function that you have built meets the spec to perform some functionality in the platform. This is a layer that we've built to enable developers to bring their own first-class logic and plug it into the platform for different capabilities. So, what do we do, right? We are pulling off our token off of our Perplexity source. It's being kept securely. We are meeting the strongly typed bindings of this interface, and we'll just make a REST request to this endpoint, and then
that's just using the standard TypeScript tools for this. This is just
exactly
standard fetch.
Cool. Exactly. And then in our return type, we'll return not just the completion, but some token usage information. So this is part of our spec here. And this means that not only will it return an output, it can actually plug into the resource management and token management tools within the platform, right? So this is probably an important part of being a first-class part of AIP. We can go ahead and tag that and publish that, which and that's published this function here that we saw earlier inside of the model catalog. What does it mean to use this, right? So it's cool that it's in the model catalog, but what we really care about is using it in AIP in the places where we would use it otherwise. So I'm going to hop over to an example of a logic file. And here we basically built a toy research assistant. So probably can't read this, but basically takes in an entity name and will say, is there any negative news, articles, or blogs, or other things about this entity that we know about? Cite your sources, et cetera. And if you're familiar with Perplexity, they actually give you the links to the websites. You can go and validate that. And down here where you can select a model, instead of using one of the Palantir built-in models, we're able to choose Perplexity here, and now we can give this a whirl, right? Let's say let's take someone who we know has gotten into trouble. Poor fellow. Not really. and here's our output, right? It's using that model as the language model in this AIP logic flow. And of course, as we try these models, in the context of our existing workflows, we want to see like how well does this work, right? And we can actually use this also in evals, right? So we can see, in other cases, is it pulling up information that we expect it to pull up, right? So it's getting a lot of things. Maybe we need to do a little bit more prompt engineering here, but by and large, it's on a number of these test cases, it's able to pull in timely data about these entities. So that's pretty cool. Seems pretty promising. So that's one level, but what I'm really excited about is not just the ability to in a simple way, connect to an existing model that you have, but to actually do more. So remember, any function here can meet the role of a language model. So what we might do is go back here, right? And let's say we have a lot of multilingual data, and we think that another language model might be better with those other languages, and we actually want to combine these two models, right? So I've come here and I've imported GPT-4o Mini in this case, and we can write a function that will pull in we'll pull in GPT-4o Mini. We can write a function here that will scan the input. And what we'll basically say is, like, if the input is predominantly English, output pass, right? Don't do anything. Otherwise, translate it to English. This is a bit of a toy example. And now we can use our previous function as part of a new valid language model. We'll call this query perplexity with translation. And what we're going to do is we're going to use GPT-4o to translate the input if needed, and then take the output and call Perplexity. And again, this is now something that we can encapsulate and use across different use cases and different workflows, right? A new valid language model. What else do we see people doing with this capability from the early usage? People who want to distribute consumer applications and want to add in guardrails around what kinds of things are being discussed, right? Input or output filters. KLM patterns for cases where different models may have different strengths and you want to actually combine them together. Fallbacks for things that are time sensitive. We've seen some of our customers want to, if one endpoint is getting rate limited, fall back to another model to improve reliability. All of these are things that you can implement in code and encapsulate as a language model and use throughout the ecosystem. So we're pretty excited about that. Maybe one last call out I'll make here is you can do this no code as well. So there's an add interface functionality in AIP logic. So I did this in a code-based way, but you'll be able to, within logic, meet different interfaces as well. Cool. Can I get my slides back? Thank you. So takeaways, you can integrate with any foundation model from AIP, right? Not just ours. We give a lot out of the box, but also any of your endpoints that you've procured, things that you fine-tuned, things that you've imported using compute modules. We saw from Cohere earlier today. We're super excited about that, right? You can use that throughout the ecosystem as a valid language model. you can encapsulate these higher order patterns and use them across projects, right? Fallbacks, guardrails, KLM, and whatnot. And one thing I didn't touch on, but you can manage these using the standard permissions inside of the platform in terms of which projects these are exposed to, right? The same permissions that you use to manage data sets, you can use to manage these language models. Of course, behind the scenes, in order to make this work, there's been a lot of work on the back end in terms of being able to do scaling. And I showed this in Logic. You can use this in Pipeline Builder. You can use this in tools that are not even tightly coupled to the ontology. So there's been a lot of work behind the scenes to make something like this work. But hopefully this resonates as a simple and obvious feeling way to engage with your own language models for the platform. I mentioned I talk a little bit more about functions interfaces. These enable developers to author and register code against our built-in features. So a couple initial ones right now, we saw model integration. We'll be adding more types of interfaces with a little bit more richness around those model integrations. But there's other kinds as well. In the geospatial case, we have an interface for a tool that we have called Gaia Assist. This enables developers to create plugins to help intelligently look for data using large language models, which is pretty neat. And then coming up soon, Agent Studio. Many of you have seen the booths around that. Super exciting. There'll be some function interfaces coming out in the coming months to enable hybrid low-code and pro-code agent authoring in that environment. Again, all of these are strongly typed and then registered in the functions registry and then served in our auto-scaling serverless infrastructure. I'll shift gears a bit to talk about reasoning on the ontology. So this is kind of the other thing that we get, right? We heard a lot about OSDK for applications, and a natural extension of that is being able to use OSDK for reasoning as well, right? Where might this come up? Either you want to use some tools that are available in the open source or that you've written that are code-based, integrating with existing Gen AI projects that you might be building using code. Or if you have very specific requirements that require you to use code. And then we do have some customers that are pushing the bounds in terms of the additional flexibility and sealing that you have, right? Making very custom control flow or state and variable management or whatnot. You can do some really neat things. So let me get my screen back. Cool. So I'll run through an example of, maybe in the, many of you have seen the supply chain control tower example. And what I'm going to do is I'm going to show you a low-code logic flow, and then we'll quickly recreate that using code, just so you can see what it looks like with the Ontology SDK. So here we have a tool, a logic flow that basically brings in a ticket. And what we want to do is we want to help troubleshoot this, right? If someone's is in the context of a supply chain workflow. So what's the first thing that happens here? We look for what are the orders and goods that are related to this ticket, right? Using the ontology, using queries to the ontology as tools and a large language model. We'll look through relevant production line manuals, right? Using semantic search against the ontology to gather information about, what might be relevant to actually troubleshooting this. And we'll also pull in other information about, principles, learnings from the feedback loop of previous operations. And we even want to be able to use a reallocation model as a tool as part of our reasoning process, or it could be an optimizer or something like that. And all of these are gonna help us arrive at a conclusion of what we want to recommend to an end user to take an action. So let's see this in code. Maybe I'll direct your attention to the left. So I've jumped into code workspaces here. We've seen a lot of code workspaces with VS Code in the last couple of days. So I thought I'd use Jupyter. I personally use Jupyter a lot in my work. This is Jupyter being surfaced in Foundry through our containerized backend with connections to all of the resources in the platform. So what do we have going on here? I'll call out a couple things. One is you can now pull in anything from the ontology. So you saw the dev console, right? You could bring in objects, links, whatnot, package those up as an SDK to use in your applications. You can also do that in code workspaces, and that basically treats your workspace as an application. And then when we save our agent from here, that will package that up and treat that agent like an application as well, but it's running on the back end instead of being a front-end app. So we've got all of those same, we've pulled in all of those same object types. We've pulled in our actions. We've pulled in GPT-4o as a model. Remember, these models are part of the same functions registry as well. They're part of the ontology. We can pull in whatever packages that we want here, right? So in this case, we've pulled in, LangChain and some other packages. These are part of the environment. They will be saved with whatever we create. And I like working with these in Jupyter, right? Because especially with something like this that was like a multi-step flow, we want to see what's happening in the middle, right? What if I change my prompt? What if I change this or that? How does that impact the outputs? We have kind of this free-form analytical environment where we can try different prompts, try different things, see what's breaking, right? And then we can structure that into code that we want to encapsulate. So what does that look like from the bottom up, right? So we probably want some underlying utilities, right? Using LangChain, right? We'll wrap that call to the Ontology SDK for GPT-4o as a LangChain language model. We'll write a React loop around this to be able to reason across different tools that we create. And now we want to give tools to using the Ontology SDK to this large language model. So, we'll have some basic tools that are just based on Python packages. But we might also want to do things like get relevant finished goods using a term search against the Ontology SDK, right? We can also write more sophisticated tools using CodeGen if we want. But so we basically have created a mirror of a number of these tools using the Ontology SDK, full breadth of what's available there. And that allows us to create an agent with a similar flow, right? So we can register all of these tools based on the Ontology SDK, and then include all of our prompts and whatnot. In order to save this now, right? If we want to capture this agent, we like it, we want to save it into the platform. What we're going to do is we're going to use the same layer that we use to save traditional machine learning models. So this is something called a model adapter. We basically define what goes in. This is how you bind it to the ontology and write a predict function. In this case, instead of this predict function running a machine learning model per se, it's just going to invoke our agent.
And that's a Palantir modeling package that you can import to just do those 10 lines to define your API there.
That's exactly correct. And then we can now save this to a model in the platform. That's kind of what this is all about. This basically saves this as a model asset, model artifact in the platform that we can then deploy and launch. So here's our model that we've saved it. I've already deployed it, right? We can check the health of this, anything we might want to do with a deployment.
So that's replicas, logging, the interface to actually call it and experiment with it.
Exactly, right. And this isn't super resource intensive because it's proxying out to a large language model, but we can set up our auto scaling policy, anything that we want to do around this. And you can see behind the scenes what it's done is it's actually captured the entire environment and packaged it up basically as a compute module. I would think of as Foundry models as basically data-derived compute modules, right? It's using the same infrastructure, and we're managing it in the same way, but we didn't have to write our own Docker image in this case. So let's go. I went back to our logic, and I just hopped onto a branch here. We call this branch procode. And what we'll do is we'll go over, and we just I have a block here that just calls that deployment as a function. You can go ahead and give it a spin, and it's outputting comparable outputs. We can use everything else that exists inside of the platform here, right? Maybe we want to evaluate this relative to our low-code version, right? So we can use this in AIP evals as well. Let's see how it compares to a previous version. Has some pros, has some cons. Looks like it might have been timing out in one case. It's something to go back and examine. But what we created using code is now a part of the ecosystem. We can use it wherever. We can run it through evals. We can use the same tool chains to make sure that it feels good and to put it into production. Cool. Let me get my slides back. One thing I'll call out, again, we use Jupyter here, and we created an OSDK from inside of Jupyter. You can, in the same way, provision an OSDK from the developer console like you would from a regular application. That lets you use the OSDK across multiple different Gen AI projects or share things with an application. You can, of course, directly author and push a compute module if you want. It's the same infrastructure no matter what, but ultimately it's about creating an application scope using the Ontology SDK and then really going wild with it and then being able to use it within the boundaries of the platform.
So if I am comfortable in Jupyter, that's where I want to spend all my time, I can do that. But then I can also go in and push that and get it into the places that my users are actually using it in the Ontology.
Exactly. And we also have users who will start off in Jupyter and then later move to a more something like more of a traditional Git repository as they start to build components that they want to keep reusing or manage in a very reliable way. Maybe just to wrap up here, right? Like you get full control here, right? You can use any package, any logic that you want. The ceiling is very high. One thing I'm really excited about here is the ontology defined safety is built in. So all reads go through the permissions layer of the ontology. It's a combination of the user's permissions plus the scope of the Ontology SDK to prevent, risks of the wrong things happening. And they're subject to the scope. Yeah, they're subject to the scope of that. And this is huge, right? We've seen so many projects where someone writes something in LangChain, it's cool, it hits some endpoints, and then they slam into the brick wall of enterprise security, right? How do you feel good about how this thing's actually going to reason over these APIs? You get that same safety from the ontology. And you also get infrastructure safety. So all of these are executing in isolated compute modules. They're subject to resource limits. They're subject to network restrictions. A lot of the fears that people have of what happens when you have a Gen AI reasoning agent that could maybe go rogue and do something or try to hit out to the web or something like that in an adversarial case, it's really locked down. So what's left on you, you have to take care of some things yourself, right? Making sure your agent's type safety is correct, that you're doing error handling properly. But you get a lot, and the ceiling is very high. A couple things coming up here. All of our upcoming investments in the SDKs will create more scope for agents that you want to write. So whether this is expanding scope of the Ontology SDKs, I'm very excited about scope for about support for media sets coming up, support for time series. As any of these come up, they are things that you'll be able to write reasoning agents on top of as well as non-ontology APIs through the wider platform SDK. Like I mentioned before, hybrid pro-code and low-code agents from Agent Studio. This is something I'm really excited about, combining some of the hard parts of things like session and state management from our service layer with your code-based logic. And then expect a lot to come on the developer experience side, right? So whether it's more flexible code-based evaluation workflows, experiment tracking, and much more.